Hello everyone, and welcome to this stream, which is not the usual stream. We generally do Rust and Advent of Code. Today we're going to be trying something different. We are going to be trying to still use Rust, but this time to do some very lightweight game development. We are just going to try to learn the basics of Bevy, one of the, I suppose, the most famous Rust game engines that you can find. And today we have Roberto as usual and Tommaso as a special guest. And none of us is an expert, neither in Rust nor game development. But Tommaso actually did a very nice talk at the most recent CodeMotion where he showcased how to build a snake game using Bevy in Rust. So today we're just going to try to explore a little bit how Bevy looks like.
We can build a worm game today.
Ooh, that could be pretty cool. But I think we'll be just moving pixels in the screen if we are successful. But let's see how far we can get. So definitely feel more than welcome to... Yeah. Okay, I'll challenge you to build a worm in 1 hour and a half. Come on. Yeah, feel free to drop your questions in the chat and to contribute. We are open to ideas, questions. Let's learn some Rust game dev together. So I'm gonna share the screen, and we can see the Bevy website, which you can find here. I'm gonna drop the link in the chat. But I'll let Tommaso start to speak about it, or not? Or do you want me to give another intro?
Let's see. So what Bevy is? A game engine. He defined itself as game engine, actually a simple data-driven game engine. Probably we would like to use Bevy just for create a game. Probably not, but surely it's born like a game engine. So we would like to create a game. If you don't want to create a game, probably is not the best solution, as obviously. So the Bevy engine actually is not introducing any news in the game world, but use a concept already present in that world, like ECS, Entity Component System pattern, that today we would like to deep dive in. So let's see what entity component system is. I don't know how to show it, but surely we need to give me the code, something like that.
Yeah.
We would like to introduce. Yeah, okay, give me the code. So I try now to share my screen.
Meanwhile, I'm going to quickly showcase the website, because there are some cool features. For instance, you can use Bevy not just for 2D games, but there is also a 3D renderer. Definitely something we are not going to be doing today, but just be aware that you can also do 3D games. There is an entire render graph, which is parallel, modular, backend agnostic, so you can build games for multiple platforms. And there is also an interesting idea of UI. So Bevy also gives you a bunch of libraries that allows you to create, for instance, I don't know, the start screen, or maybe you can even build UIs inside your game if you want to do like drag and drop or this kind of things inside your game. Then you have a concept of scenes where basically you can transition between, I don't know, the start menu to the first game scene to, I don't know, ending scene where game completed or something like that. You can manage sounds. There is hot reloading. So for instance, there are plugins that allow you to draw maps, and then you can have the game running and you can update the map in real time and the game will reflect the changes. So that's actually a nice experience if you're trying to experiment with game level designs or things like that. And yeah, there is a lot more. I'll let you explore all the features, but because I also want to look at some code.
A nice probably is needed to mention is the cross-platform, because if you want to deliver some games, you will not like to exclude any platform, at least for the starting point of view. But Bevy can compile to WASM, so it can be run inside the browser. It's a really nice feature of Bevy. This is why we are here to talk about it.
I think other examples
we are not ready to talk about that, but surely is really nice.
I think on the website under examples there is something running in the browser.
Actually, let's quickly try that. Meanwhile, Tommaso, let me know if you're able to share the screen.
The examples are also in the repository of Bevy, so with cargo run example, you can run all of those examples.
So this is a breakout game.
Loading the
you can probably see here. Now I'm not even playing, but yeah, this is basically a Wasm game compiled from Bevy. The
Quite
sound is
noisy.
very annoying. Yeah.
Yeah.
Sorry for the annoying sound. Okay, so I can see that you were able to share your screen, so I'm going to transition. And I'm going to ask you the most annoying question. Can you make it bigger?
Okay. So let's start from here. Here we have the piece of the starting point, means main. As always, we have a main. And here we are instantiating the Bevy app.
Can you make it one point bigger, Tommaso, the
starting
text?
Point. Oh, yes. Better?
I think so.
Yeah, fine for me.
Another?
Thank you. Yeah, this is better. Perfect.
Why not? Yeah, a little piece of code. So the app actually does nothing by itself. He actually started the life cycle of Bevy engine, nothing more. Bevy supports a lot of plugins. So if we want to show, for example, a window, we need to add window plugin. If we want to show, to load some images, we need to add asset plugins and so on. Because we don't want to choose which plugin we want to really add and which not, we add just the default plugins that actually concatenate bundle all the plugins basically we want to add, typically we want to add in just one call. Add our plugin called example plugin, and after that run really the application. So as you can see, the main is just a definition of which plugin we want to add. What is a plugin? I don't know how to define it, but contains a lot of stuff. Contains some functions, some definition, some sprites, some input handler, and so on. Conceptually, encapsulate a unique piece of your game, called like that, in order to put all the stuff in a unique file, something like
So
that.
when you develop a game, basically you can take the approach of writing plugins, plugging all the plugins in the app and running it.
Probably I have some networking issue, Roberto. I didn't hear you at all.
Okay, I was saying, so can you develop all your game like a collection of plugins?
Yeah, so basically, I'm going to try to answer the question. I think so, because what I've seen is that basically what people do, they either create one big plugin, as Thomas is doing here, and then all the game logic is inside that one big plugin, or they do like smaller subsets of the game are individual plugins. And there are also third-party plugins to do all sorts of things, like, I don't know, manage the camera, manage artificial intelligence of non-playing characters, all these kind of things.
Okay.
There is also a plugin, for instance, to load a particular type of maps. So there is like an open source editor for maps, which creates all the maps with a tiling system and then provides JSON files. So that's another plugin you can install if you want to load this kind of maps in your game.
In fact, Bevy have a lot of plugins. You can use it by provided like that help you to develop your game. So really nice in this way. So start from our plugin. I call it example plugin. And let's see what the plugin looks like. It's just a merely struct, as you can see, nothing special. I love really Bevy because I use the plain Rust, nothing special, nothing strange stuff. Is really, really nice. And this is not so common in game engine. So declaring a public struct, for example plugin, and let's implement a trait of this for this struct called the plugin. Plugin trait requires to implement a function called build, allowing us to create some our starting point for our plugin, call it like that. In this case, we have just want to add a startup system, and now we are entering what is a system. ECS, the S stands for system. This is just like a function, actually is a function, as you can see, that accept some parameters, changing the world and stop. No output is required at all.
Can I stop you for a second?
Yes.
I'm going to try to give my own definition, and you can tell me if it makes sense or not. Because we also say that Bevy is a data-driven game engine. So basically, you can imagine that entity and components are kind of the data part. And you can imagine as entity as anything that is part of your game, like any actual entity, any object, if you want, that is part of your game. Like, I don't know, the main player, every single tile, if you have a tile-based map, particles that are moving in the screen, anything that makes sense in your game as an object, as a game object, is an entity. Then components are actually features of your entities that you can actually attach to the entities. So you could say, I don't know, this particular entity as a mass, as a velocity, as a position in the screen, as a particular sprite. And basically you create entities and then you attach all the different features to that entity, and these are components. And you can imagine all of that as a big table where on one side you have the list of all the entities, and on the other side you have all the possible components that you can attach to every entity. And this is your data. This is like a big table with all your data. Then you create systems to actually query this table and do something with it. You can manipulate, for instance, changing the position of an entity, or you can, I don't know, change the sprite of an entity if you're doing an animation. You can reduce the health of the player, for instance, if you're hit by a bullet or something like that. Does that make sense as an explanation, or?
Yes, you anticipate actually what I would like to show it now, because we are talking about system and world. I talk about world, but what is world? Question mark. World is all your game world, and not only that. As Luciano said, your game is composed by images like sprites that move among the physical world, itself, a camera, some material, if you want to have some effect on lights, for example, and so on. For the time being, we start in easy way. So our target put a square inside our screen. So this is our target today. And let's see if we are able also to handle arrow button in our keyword in order to move that square. Let's see what we can do. So basically, starting from this start point of view, we would like to, first of all, spawn a camera in order to see what we want to see. The camera is more like, hey, I have this window, I would like to see those entities. In this case, our entities is just 2D, 2 dimensions entity. So what we will see is square, more or less, and lines, if we want. Instead, if we want to show also 3D bundle, three-dimensional model, more complicated stuff, we need to change our camera in order to show them. But let's see in easy way. Start from the time point of our point of view. Start simply in simple way to spawn a square colored. I don't know. We insert a random number. Let's see which color appears.
Yeah, people drop your favorite color in the chat, and we'll pick the most favorite color.
Yes.
In the chat. Yeah, you answered it. Yeah.
So let's start. We receive input of our system a Bevy entity. Actually, is a Bevy object called commands that allow us to spawn, so to create a new entities in our system. So we are able to put a new square inside our screen using commands object. Before doing that, I would like to show you what we are here, just spawning 2D camera and so on, and stop. So
It's compiling.
If compiling is already made, I suppose. Yes, hopefully.
We need a compilation song. Please hold. Compiling.
We can ask some random AI to create
just
it.
showing empty empty window.
Yeah, meanwhile, while we wait, I'm gonna mention something that one of the cool things about Bevy, but also one of the black magic kind of things that I've seen with Bevy is that we said that every function can be a system, right? You just register it and it's gonna run on a schedule, basically in the background, and it will continue to query your data and do whatever the system needs to do. For instance, keep moving objects based on their velocity. But the crazy thing is that the way you query the data is by defining different parameters as arguments of your function. So we see here we are all using commands, but we will see that you can put different kinds of parameters, and what you put as function arguments is actually what defines the query into the data system. Now, just a little bit of a spoiler, but it's a bit crazy in my opinion, and I have no idea how it's implemented behind the scenes.
So we are not writing SQL.
Yeah.
No, we're not writing SQL, but basically by using the Rust type system, we are basically implementing queries. That's the crazy thing to me. Like how you define your types is what eventually creates queries.
More or less.
We have Minix in the chat that says that he did something similar in C#. So that's great. I drop some links in the chat if you want. We'll be happily check them later. Sorry, Tommaso, go ahead.
This is we want to own something of our window. Let's just there. To do that, we can use, as already said, commands that allow us to spawn a new entity. Spawn a method allow us to spawn a new entity and add call it component to this entity in order to attach to that entity, for example, an image or a color or something. In this case, we would like to add a sprite. So, insert bundle, sprite, bundle, sprite bundle, we can put.
Should we explain what is a bundle, maybe?
Yes. If you want, you can try to explain what a bundle is. Bundle conceptually is a set of stuff. In this case, it's a set of a sprite bundle. In this case, a set of the image, for example, the position of that image inside our world, and other stuff. Now, probably we can see what a sprite bundle is. Color. Let's see which is the color we want to.
No, nobody said anything, so I'm gonna say blue.
Blue. Blue means
you can probably say
this
0,
is 0,
0,
this
1.
is 0, this is 1.
Because they are float, okay.
Default.
By the way, speaking of bundles,
in this case we are.
Sorry, Thomas. Speaking of bundles, we mentioned that you have entity and components. So when you say spawn, the way I understand this is that you are saying create a new entity. And an entity is just an ID, like a number that says something exists and has attributes. Then what are the attributes? It's basically components. And a bundle, my interpretation of a bundle is nothing else than just a collection of components. Because most of the time you don't want to add components one by one, but you want to have, for instance, to have this idea of a sprite. And a sprite has an image, has a position, rotation, a bunch of other components. So this is like a nice compact way to say, give me all the default components that make sense for this kind of thing, which in our case is a sprite. So for instance, we could have created our own custom sprite in a, I don't know, tower defense game. You could have, I don't know, a cannon, whatever. That could be a bundle that contains all the components that make sense for that particular kind of entity.
For example, if you want to, we can investigate what sprite bundle is. As you can see, there is a sprite, so the image, the transform means rotation, translation, scaling, and so on. Could be also transform, global transform. I don't know what is this.
I think that's a global transform is when you have, because you can also have children items. You could organize entities in a tree structure if you want to. So global transform is kind of the idea that if the parent moves, all the children will move respectively as well.
Could be. Yes. Yes. Could be. And also texture, the visibility. We can hide, I suppose. Yes, it's visible to Boolean. I don't know why, but probably you would like to hide, because spawning and despawning entity or component and so on cost a lot. So probably it's better to hide and unhide when you want to respawn the similar entity in another place, for example. So sprite bundle is this. As you can see, is more than one component, so more than one attributes we would like to add our entity in order to let the camera show it. Mm-hmm. This is more like what sprite bundle is.
By the way, again, we are not. Yeah, we added that default plugin. So I assume, and this is something we should maybe check later, that default plugin also has a system that recognizes all the sprites and knows exactly how to display them in the window. So this is why hopefully we are going to be seeing something, even though we are not manually writing all that code to take this sprite and display it.
So let's see what we write here. Let's run again. At least we test it if it is shown what we are expecting. Should be hopefully a sprite at origin position, so in the middle of our window. The sprite should be just a square colored by blue. And as you can see, I am completely wrong. So we are missing something.
Do we have to specify the size of the sprite?
Transformation. I suppose without any transformation, the component is not visible at all. So let's add the transformation, the scale, the translation we talked before to our bundle. There is transform here. So translation.
You can probably leave that as a default, right? We probably just need the scale.
This just the scale.
I'm making a guess. I think just the scale is enough. We can try.
Could be. Why not? Because probably it's there, but just 1 pixel.
Yeah, or 0 pixels.
Or 0, depends on the default. No, Tommaso, no, like that. Just put something. Okay. Let's rerun it again.
I think Rust Analyzer is conflicting.
Yeah. I didn't know how to avoid it. It's a bit annoying sometimes.
So let's see. We need to be patient.
Let's see.
Oh yeah, why did you put Z equal to 30? That did work, so good job.
It works. It works. What you are asking?
So the last argument in the scale, that Z parameter, is that like a Z index, I guess, in web design? How does it get interpreted in a 2D space?
Good point. Z for scale, I don't know. Z for translation, keep the order. So you can put something upon other stuff using Z.
Okay, so it's like a Z index.
So
Scaling,
scale be a vector.
yeah. On
Scale
scale,
must
I
be
really
a
don't
vector
know
free.
what this means, but we probably put 0, 1. 0 probably not. Surely 1 should be fine, but let's see.
I have 0 in my example and it works, but I don't know.
I don't know why, but probably zeta not completely probably. But I not be guess. Not.
Maybe it's only used if you use a 3D camera or a 3D renderer.
But anyway, yes. So as you can see, we put our square in the middle of our window, and also if we resizing it, stay there because Bevy redraw it automatically. So we achieved our first goal. So good for us. We would like to handle also the arrow keys because we want to show what in general system is, because now we show just the startup system. It's called once at startup time, but we can add other system function that runs every frame. So in case we can move our square around. Let's start. Add system. Yes. Move. Okay. This is function called every frame. For be sure, put something like that. And put setup here. What I'm expecting is that setup is shown in our console just once. Instead, move square multiple times, once per frame, more or less. As you can see, using add system, we can define this kind of function invocation. So we can define a function called as you want, accepting for the time being 0 argument, and let and register it in this way. So running.
Is there a way to have an idea of how many frames?
Move square is printed multiple times. So this is how we can handle input, how we can change our world. In our case, we want to move the square.
So to answer Roberto's questions, I think there is a way to show how many frames per second are we drawing. I don't remember exactly how, but it's like, again, something you could query in your own system to get that information, and then you can display it somehow. No, this is not a great answer.
Surely on my PC, yes, but surely on my PC, no big performance. I'm stringing, I'm compiling, so you are not expecting 60 FPS, surely. But yes, Bevy has, yes, sorry, has a plugin to show on the top of the corner, if I remember correctly, the rate.
I saw there is even a third-party plugin that gives you like a widget. There's like a mini debugger that shows all the entities, and you can like expand it as a tree, like a browser type of developer tool or something like that. So nice. we might try that later if we have time.
Yeah, no, just to make a parallel with Pygame, there is the clock object typically in Pygame, and you can limit the FPS with that one, but also get an idea of how many FPS are you doing at every loop.
Yeah, it might be nice to
Because
do.
you can limit
With a
them,
question.
because if you...
Yeah, it might be nice to do in one of the next sessions a comparison with Pygame, since we like to do Python versus Rust comparisons.
Why not continuous? Why not? Yes. So let's start to move our square. First of all, we need to do two stuff. Knowing which button is pressed in our keyboard, and where identify the square. So Bevy used two different techniques for handle those two stuff. Event for listening which keyboard button is pressed, and instead query for knowing which is which is which is the sprite we want to move. So starting point, the keyboard handling. So we for the time being we want to print which is the key is pressed, for example. For doing that, we leverage on the Bevy basic functionality, like input and keyboard code. So here, as argument, we want to add which is the keyboard button is pressed. For doing that, we can define a parameter of this function, handled completely automatically by Bevy. We don't need anything. That is a resources. What is a resources? Question. Resources is a share of resources. How documentation explain better, obviously. Joke apart is something we can is more like a singleton in our pattern. So for the Bevy can register just one. Actually, in this way, there is other way to handle multiple button pressed. But for the time being, we can start simply in simple way. So we want to know which is the just one button we pressed. We can use resource because Bevy describe input resource. That is again another generic for key code. So
yeah, for instance, talking about resources, that there are other things, like for instance, there is a resource called time, which allows you to get some information. I think it's going to be similar to what Roberto was suggesting before in terms of how much time has been elapsed since the game started, how much time has been elapsed since the last frame, all these kind of things. But it's like a singleton that exists, and you can import it, so to speak, into your system by doing this kind of type declaration.
But this is a little bit like dependency injection in the end.
Yeah, it's probably a good way of describing the idea. And again, this is the part that to me is a little bit of black magic. I have no idea how they implemented this, but probably some way that looks similar to dependency injection.
Yeah, because there is no reflection in Rust, right? So for sure, not with reflection.
I think there is some way to do reflection, but yeah, I don't think they will be using that here.
Yeah.
Under the hood, the reflection is made because Rust create a type ID for every classes. Under the hood, type ID. Wait a minute. Let's see what we can show here. Type ID. This is the under the hood what is used. Typically, Rust at compile time create during resolving generics and so on, create a dedicated unique ID called type ID for every classes. And under the hood, he use it for registering, for example, component, query, and so on. This is what Bevy use.
Okay, so there is a little bit of reflection at runtime.
I think so. it's like optional. Like if you want to use this feature, is there. I don't think by default every object, every like struct that you instantiate gets that reflection feature, right?
It's not a reflection because at runtime you don't know it. You don't able to.
It's a compile time reflection.
I don't know how to use it. Really don't.
Because that type ID is a trait, right? So you need to explicitly implement that trait. Is it?
No, it's a struct.
Oh, okay.
It's a struct. It's automatically implemented for every for every struct you implement. At compile time, he generates a dedicated type ID. So if you want, for example, knowing which is the type ID of something, you can call this function type ID.off, passing.
I'm
this,
not seeing the screen anymore, guys.
Oh yeah, you stop sharing.
Why?
Very good question.
Please share again.
Sorry for the inconvenience. So you can use this .off function that will let you know which is the type ID of your object. I don't know if it is good or not knowing this, but this is the typical stuff you don't want to know.
Yeah, at least not at our level of Rust knowledge. Maybe when we will be building game engines ourselves, that could be interesting.
Yes, next level, next life.
Okay, so let's get some keyboard events. So
we want to know which is the keyboard button is pressed. So let's see. Keyboard input is a resource that implements the ref. So automatically we can invoke method of input without differentiating it explicitly, at least. But if we want to do it, we can put like that. This is a differentiating, so obtaining input, but because input doesn't implement copy, we want to reference the input. So what this statement returns is the reference of this. More or less.
Okay.
Here the input is just a struct that has an hash set as pressed. So we can ask to the input which is the button is pressed. Let's see if we
and
can
you can distinguish between just pressed and just released, right?
Yes, if we want to do it, yes, why not? I suppose we can use this function, sending to input the key code of arrow function left, right, up and down. So if input pressed key code left, do our stuff. Let's print left pressed, something like that. If we run this, we can see we see the output console when we press the button. Obviously, we can handle multiple stuff here. It's better to have copy paste, something like that.
Yeah, I don't know. What do you want to do? Do you want to just raise events or something like that?
Sorry.
Are you gonna use events?
How do you alter the sprite?
Yeah, or do you just query the sprite
No.
somehow?
Yes, we need to query the sprites. So after that, we have the opportunity to know which is the button is pressed. So copy and paste, left, right, up, and down. But we want to know which is the sprite we want to move. So we need to query our world in order to know which is the entity we want to move. To do that, we need to make this entity identifiable. I suppose we can say in English like that, adding a dedicated component. So, for example, suppose we have a component, for example, called square.
Or player, square. Yeah, whatever.
We can use what?
Or player, yeah. The idea is that we want to player, yeah, whatever makes sense, because now it's a square, it could be a character, right?
We can use this in order to attach the entity our component, our dedicated component. We need to define it. What is a component is generally is a structure, plain structure that derive component. In this way, we create and define and create a component. In this way, instead, we attach a component to an entity. So now we can, because we add this, the entity is identified by this component. So we can ask to our system, which is the entity that have that component. How we can do that? Querying the world. So another argument of our system function is query. Query is a Bevy struct that contains strange stuff, strange reference to world, to state. I really don't know what is that, but if you want to investigate, please let me know and give me your anyway. Also give me help to know how we can do that. Anyway, what we can query? We want to query the old entity that have player component, but we want to have also the sprite, also visibility, and so on. Probably not. We want just its transform, because we want just to move it. So actually, we don't care about images of our entity. We want just the transformation. So and because we want to mutate it, we want to have a reference of a mutable reference to the transform. So transform like that. But in this way, we capture all the entity that have a transform, and as said before, we don't want it, just the query, the entity that have player component. So we can use the with query, put like that. In this way, we can query all the entities that have player and obviously the transformer, and we can use in the query, the projection of the query is just the reference, a mutable reference to the transformer. So we can ignore completely the image, for example. So as you can see, is almost the same as a SQL query, where this is the where condition and this is the projection. So select start. So in this way, we can have a mutable reference to the transform, to the position of our square. So because we know that the player is just one, we can avoid to iterate over the all the entity that match this query, because it's just one, we can ask the query to just the first mutable reference to it. So query dot single mutable. Let transform. And as you can see, this returns a mutable transform, a mutable reference. Okay.
Go.
So in this way, because we know that query, the identity is just one that matches this query, we can do this. If we know that the query could return more than one element, we can iterate over it in this way. Transform in query dot here, something like that.
You probably need iter mut, right? If you want a mutable reference.
Yes. Sorry. So in this way, we have a reference to the transform. So let's do that like that, because generally you have a multiple matching entities. So we can do transform dot translate dot translation. Let's see, dot x, yes, dot x, left x, yes.
So it's probably minus
plus
equal
negative.
One.
Is it minus? Equal?
Negative. Left is probably negative. So
left, this is the left, this is the right, this is the left. Yeah. Understand? Understand your point? The right is just plus, the up is epsilon, up, yes, plus, and the down is epsilon minus. This is not good at all, so we can put it like that. Delta.
You are not doing multi-cursor magic like Luciano. You have to learn.
Okay. And this, what we can do is more like that. But again, because our, because our frame rate is not a constant, we need to use time in order to know which is the delta we have comparing the previous frame. So conceptually, we have multiple frame, one after another, and the calculation of every frame can be different for a lot of reasons. So the time is not so constant, and we need to know how many seconds passed from the previous frame.
So basically, it is possible that it is possible that because of performance you are skipping frames, but we still want at the end to render the object in the right position, right?
Exactly. Yes.
Okay.
So for have a smooth moving as possible, we need to multiply the delta. Otherwise, we have a flaky movements, not so smooth. So time dot delta seconds. Delta seconds returns the delta between the current and the last tick. Tick for Bevy means frame. So in this way, we can keep our movement constant in the time. So if I continue to press a button, the square move constantly without any acceleration, something like not so good to see. So let's see what we develop. Should run properly. Should.
Fingers crossed.
Let's see. Fingers crossed. Compilation take time, as always. So here we have our square. I just press
and
button and nothing happens.
Yeah. The logs before were telling us left, right, and everything else, yes?
Yeah.
I didn't.
We did remove the logs, basically, saying left and right.
Yes, we move it.
Yes,
I suppose
try to
this doesn't
try to
match
add the
anything. I
back
don't know
in.
why.
Try to add the print line back in to see if we go inside the for loop. Luciano, can you relate this?
Yeah, I don't know if you, Tommaso, if you're reading Roberto, it's suggesting to add the print statement inside every if branch, just to see if we are getting there. Oh, okay, you think that the query was wrong. Cool. Let's add as well the print statement, just in case.
Yeah.
But also inside the if, right?
At least one leaf, at least left.
Let's see if the input is the bug. Perfect. We can literally debug the input here.
Oh, I like the new syntax.
Yeah, me too, a lot.
Oh, he didn't like it.
Let's. I don't know where to put the input. Not here. Here. I don't.
Okay.
Don't remember. Probably here.
Seems to be happy with that.
Yes. Here. Okay. I forgot always. Or just probably our velocity is very, very low, because thinking about this means we can move our square
1 pixel at the
for
time?
me is working, but our velocity is very, very low. Let's see to put some zero here because the frame rate is less than 1 second.
Yeah.
Probably. So the velocity is the problem. So let's see. This is what you are facing up during your game development. How fast we need to move our entity? Just put one. No, one is not working. Put more than one.
Okay, now it's moving. Beautiful.
As you can see, you can move or just developing. So you can more than one at the time, as you can see.
Yeah, you can also go diagonally, right?
Yes, like that. Pushing 2 buttons at the same time. And as you can see, the input, if I press P is there, but obviously we ignore it completely. So it's not working just for the arrow function only. It's more generic.
Roberto Scat is interested.
So we achieve in our goal, right?
Yes. Can I suggest a new challenge if you have other 10 minutes?
Yeah.
Challenge accepted. Okay. So because you explained that we can query multiple entities,
yes,
right? We could technically create another player, maybe position it somewhere slightly not overlapping the original player. Like we create another player that is red. And then if we recreate that for loop you were doing before, every time you move, they should be moved in a synchronized way, right? Does that make sense?
Good point. Yes. Yes. So put it in the for play.
And let's check if it works.
like that here. So nothing changed, just allowing multiple entries on as a return value for our query.
So this should still work as before, right?
Yeah, nothing changed. So supposing we want to add another player and the same condition, but translated by some values.
Yeah.
Obviously, as the start point, we need to change it. So translation vec 3 new translation.
We can do 60, 60, 60 or 100, yeah.
Okay, something like that.
Can you also change the color? Let's make it red.
Yes, I like red. Okay, so what we are expecting? First of all, we have two squares. One starting from the origin colored with blue. Another one start from 100, colored with red. When we press our button, we see both
players
square
moving, yeah.
Players moving. Yes. Not here, sorry. I don't know why I put here. One nice functionality of Bevy, feature of Bevy, sorry, is to parallelize your system. If the query doesn't overlap, for example, immutable way, and ask a mutable reference to your component, Bevy is capable to parallelize your system. Let's see after that. So this is our starting point, the origin and 100 to 100. If I press left, both move in the same way, obviously translated.
Okay, you want to get challenge number 3?
Yes.
Well, first of all, good job. The other challenge is, what if every player has a different step size? For instance, player blue moves by 10, player red moves by 5. How do we implement that?
Okay. Okay, how to implement it, for example? For example, we can differentiate the behavior on the arrow button. We can do in ugly way or in better way, depends. Let's start straightforward, changing this velocity value depends on the player, for example. I understood correctly?
Yes, I had another solution in mind, but I think that's this is the shortcut, the one you're suggesting, right?
This is the shortcut, yes.
Yeah,
this is the ugly way. The ugly way is to put the value inside our component. We have a dedicated component, so we can leverage on it to know, to differentiate the velocity. For example, put F32 value, pub, why not? Pub. And here, the blue move at velocity 20, and instead the red move on in this way. So we differentiate it. Now we need to have this value. How?
Yeah, you need to project the player as well. We only projected the translation.
Exactly. So we need to change our query in order to let the query return also the player component. Remember that the query is capable to return only the component, not the other stuff, just the component. So if you want to differentiate, for example, if you want to put a health or the number of the shot somewhere, you can put it in your dedicated component. So to do that, we need to create a tuple where we want to have a reference of a player. A reference, just a reference, not a mutable reference, because we don't want to change it. So we can access it in easy way. Because we put a player in our projection, is implicit that width is already made, so we can remove it as well. So our query, what returns a transform and the couple transform and the player. So we can put here player and leverage on the player value to calculate the delta for every. Dot 0. In this way, we can we have a different behavior on different player.
Okay, let's see if it works.
You don't trust me.
Yeah, another 10 minutes of compilation.
Exactly. We just want to burn your CPU.
Compile time.
Why not? Another approach is not to put your data inside the ACS directly, but to leverage on something like trait, for example, to have multiple or difference or parallelize. Because in this way,
Wait, I'm not seeing your window. Is it in another screen?
Yeah.
Okay.
Sorry.
I want the proof.
So I just press left as usual, and as you can see, the velocity is different.
Mm-hmm.
I am expecting a wow, no?
Nice, good job.
Wow.
I don't have sound effects like the
So,
fancy
nothing.
streamers.
In this way, we can, but in this way, we don't parallelize the translation because the move square is just one. If you have multiple lot of entity that you want to move, a different approach we need to care about. So, but not today, really.
I had another idea in mind. I don't know if it makes sense to explain that, but I was thinking we could have created another component called, I don't know, velocity or step, whatever. And in that component, we could put the value of how much do you step.
Yes, depends on what we want to do. Move a player or move all the stuff is capable to move is different. In this way, we want to move just a player. Instead, if we want to create a more general solution in order to let a user to move all movable object, something like that, we can implement another component called movable. Is in English word movable?
I think so, yeah.
Why not? Put an able at the end of what we want, we create. So here we can put a struct. Let's do in better way. The velocity, speed, something like that. Put the player, insert. Here, movable, speed. And here remove. This more generic solution allow us to define also player that is not movable. For example, if we want. In this case, for example, just the blue entity is movable. Instead, the red one is immovable. So, for example, in this way, we can ask not a player, but all movable object. We can do that. In this way, we move all entity that is capable to move. Instead, if we want to filter this entity for another component like player, we need to reuse with player. In this way, we are able to iterate all the entity that have a player, movable, and transform. And we want to project to have in our for loop just a mutable reference to transform and a shared reference to movable.
That movable can be added and removed from the player at runtime, or is it defined on compilation time? You can't change it anymore.
It is movable.
I'm going to relay the question because I don't know why Tommaso cannot hear Roberto. The question is, can you attach and deattach components from an entity at runtime? Or is it like once you spawn?
Yes.
Yeah. Okay.
Okay, good question. Start instead of creating this second part, just creating using a space button a new entity in an origin position. Starting simple like that. So try to spawn it a new component. Square on space. Space seems space, but anyway, on button space. So again, we want to leverage on keyboard input. We want to spawn a new component, a new entity. So we need to ask to Bevy to give us this the opportunity to spawn a new one entity. For spawning an entity, we can cut it. Do it. This actually will spawn every frame a new entity. We don't want it. So what we can do is put just an if here to ask if space is pressed, not pressed.
Or just pressed? No.
Or is there something like just release as well? Just pressed or just released? Which is maybe more deterministic. I mean, it's more, you need to release to spawn one.
I don't remember which is the just pressed. Okay, something like that. Yes, at least we don't track every frame if the tab is, if the space is pressed, but just when the frame handle the press action, not if the right keyboard input.
But because you are using
res implements.
Sorry, Thomas. Because you are saying not just pressed. Is that the right thing we want to do? Or
Yeah,
should we just?
Yeah, it returns.
Yes.
But if you keep it pressed, what happens?
Good point. Let's see, like that.
Yeah,
if it pressed, respawn it.
And this one is not movable because there is no component movable in this one.
Oh yeah, this one is not going to move, right? Because we don't have the movable component there.
No.
Okay. Which is fine. It's just a question.
Yeah, no. But we can add insert movable in something like that.
Mm-hmm. Now, how do we make it random is an entire other conversation, because otherwise we're going to see... Actually, well, we can move things around, so it's just going to spawn in the same place.
Yeah. Spawn, move, spawn, move, spawn, move.
Random, we probably want to...
Time. Yeah, let's not make it random for now. Like we move around, we create space, we spawn, we move around, create more space, spawn. Right?
Actually, we can do it better because we have the player. We can introduce the enemy. Why not?
Mm-hmm.
And spawn on the space at enemy. Obviously, we move all the part, so probably it's not a big... no, stuff like that.
Okay.
Next
time, yeah. I have other ideas, but I'm not gonna mention that. Otherwise, we stay here forever. like we spawn enemies, and then there is a system that makes the enemy chase the player. But no, that's not it.
We can create Bevy support also multiplayer and networking stuff. So if you want to leverage on some backends, you can do that.
Nice.
Just for, I didn't test it yet. So press the keyboard. As always, our player is moving, not so fast. I pressing space, and there, yes, I forgot to change the position, but the position is 100, 100. Press another space, another red is spawn, another press, red is spawn. I can continue to press and keep the left button pressed, and it is work, as you can see.
Nice.
Good.
I think that's it for the day, unless there is questions from the chat.
I don't see any.
But just to make a recap, what we saw today is basically, well, what Bevy is, which is a game engine that allows you to, gives you a bunch of structures and constructs to define your game logic. Specifically, it uses this ECS model, entity component system. So entity and components are like the data of your game. Then systems can query that data and alterate the universe doing different things. We saw moving things in the screen at different speed or spawning more things. You could also despawn things. For instance, we could have, I don't know, a timeout. Every square after 10 seconds is going to disappear. You could create a system for that. So yeah, I think we saw more or less the basic ideas, but then of course you can implement all sorts of different logics with that. We also saw how to interact with the keyboard, how to read the current time. So there are all these concepts of resources that you can use to do all sorts of things. The keyboard maybe could be a controller if you really wanted to. We didn't see that, but I think Bevy supports also like gamepads type of controllers. So yeah, it's just up to you to do all these kind of things. We didn't see things like audio. Probably that could be another interesting thing to check, or how to load images from files like PNGs, or I don't know, sprites with like animations and how to animate them.
Next time.
But Bevy also supports this kind of sprites where you can have animations and you can have different, I don't know, for instance, we could have different positions of the character, like looking up, looking down, looking left, looking right. So there are all these things that Bevy gives you, and then it's up to you to build a game with these things. Now, are we going to make the source code available somewhere? Tommaso, do you want to put it in a repository, or I don't know?
Yes, why not?
Okay, so what we are going to do... What we are going to do is we are going to put the video on YouTube, and I'm going to share here the channel URL when the video is going to be available on YouTube. You will find the link to the repository in the description. So with that being said, thank you very, very much for having been with us today, and we will see you next time, which is probably either next Monday or next Wednesday. So make sure to check the schedule, and yeah, you'll be notified when we are live next. Bye.
Bye.